Welcome to TalkTensors. Today, we're diving deep into a really significant academic contribution in machine learning.
Yeah, this is AI Agents, Evolution, Architecture, and Real-World Applications. It's by Navine Christian, just came out in March.
And it's super timely, right? It really tackles the progress we're seeing, moving beyond those, narrow AI systems.
Exactly, towards these more sophisticated, autonomous AI agents, the kind that can operate across loads of different tasks and environments.
Yeah, what makes it so important, I think, especially for the ML community, is how it focuses on systems that don't just, process information.
Right, they actively perceive their environment, they reason about it.
And then act.
Yeah.
Independently.
Yeah.
And they learn, adapt based on what they experience. It feels like a real shift.
It absolutely is a paradigm shift in how we design intelligent systems, how they achieve complex goals.
And remember Kapoor and colleagues last year, they highlighted how these agents designing their own workflows, using different tools.
Yeah, not just language processing, but actually using tools. It opens up so many possibilities for real-world impact across loads of industries.
So this paper gives us a great lens to understand that rapid advancement.
Definitely.
Okay, so in this deep dive, we'll summarize Christian's main arguments. Then we'll step back a bit, look at the history in ML that led up to this.
Put in context.
Exactly. And finally, we'll do our usual thing, explore some novel research ideas spinning out from this work.
Sounds good. And for anyone wanting the nitty-gritty, the link to the full paper will be in the description.
Perfect. Okay, let's get into it. Christian's paper.
Right. So Christian kicks off by emphasizing just how dramatic the evolution in AI has been over, say, the last decade.
It really has. From very specialized systems
to these increasingly sophisticated autonomous ones. And the paper positions AI agents as a really major development here.
Embodying a fundamental change, right? In interaction, decision-making.
Goal achievement, all of it.
And Christian gives a pretty clear definition, too.
Yeah, basically, an AI agent is an autonomous system. It performs tasks for a user.
But critically, it designs its own workflow and uses available tools.
Exactly. It's way beyond just information retrieval. It's decision-making, problem-solving, interacting with the environment, executing actions.
And for us in ML, the paper stresses how breakthroughs in, large language models have just massively accelerated this.
Oh, absolutely. LLMs provide this powerful foundation for reasoning that we just didn't have before, not at this scale.
That ability for in-context learning seems key here, right? Letting agents adapt and use tools without tons of specific training for every single task.
Precisely. That's the game changer. So modern agents, they take these powerful LLMs
and augment them with specialized modules.
Right. Things for memory, for planning, for using tools, interacting with the environment.
And that combo lets them tackle stuff that was, frankly, unthinkable for older AI, like reconciling financial statements.
Or giving super specific instructions to a field tech based on real-time data feeds. Complex stuff.
Yeah. And the paper makes a really important distinction between these agents and other AI systems.
It boils down to autonomy, doesn't it? That greater degree of autonomy in pursuing goals.
Christian mentions Jared Spataro from Microsoft.
Describing agents as these layers on top of LLMs, layers that handle observation, collecting info,
feeding it into the model, and then together they generate an action plan.
And sometimes even execute it autonomously.
Which naturally leads to the question, how do we even categorize these things? They're getting so sophisticated.
Yeah, Christian walks through the evolution of the taxonomy. Starts simple.
Like simple reflex agents, basic rule-based stuff.
Right. Then model-based agents, which have an internal picture of the world, better for, partially observable environments.
Then goal-based, utility-based, focusing on maximizing some reward.
Learning agents, obviously crucial for ML, improving with experience.
And even hierarchical agents, breaking down big tasks. AWS is mentioned as a source for some of this classification.
And it's important to remember, as the paper points out, the innovation here is happening fast. Both in academia.
Like Princeton working on benchmarks.
And in industry. IBM, Microsoft, AWS, Anthropic, they're all heavily invested.
But, and this is crucial, Christian doesn't shy away from the challenges.
No, definitely not. Big hurdles remain, like reasoning capabilities.
Getting them to be truly robust.
Yeah, and tool integration, making that seamless. And evaluation, how do we actually measure progress effectively?
Cites Kapoor et al., again there, about current benchmarks often being too narrow. focusing just on accuracy.
which can be misleading. So the paper really aims for a comprehensive look: the theory, the architecture, evaluation, applications.
It lays out a clear structure: lit review, core components, evaluation practices, applications, challenges, future research.
And highlights its own contributions too, like a unified framework, a critical look at evaluation, analyzing applications, and spotting research opportunities.
So that's the paper in a nutshell. Let's maybe dig into the history now. How did we get here in machine learning?
Right. The literature review section really grounds this. It shows AI agents aren't just some new fad that popped up with LLMs.
No, the roots go way back. Computer science, philosophy, cognitive science.
Even back to distributed AI in the 70s and 80s. But the modern concept really started taking shape in the 90s.
Russell and Norvig in 95, right? Defining an agent as something that perceives and acts. That core perception-action loop.
Exactly. Still fundamental. And Wooldridge and Jennings, also 95, added those key properties: autonomy, sociability, reactivity, proactivity.
Concepts that are still incredibly relevant today, even with totally different ML techniques underneath.
And theoretically, it's interesting how the paper brings in agency theory from economics and psychology, the agent acting for a principle.
Which connects to how we define goals and rewards in our ML models for these agents.
Definitely. And the idea of rationality, the agent trying to maximize its expected outcome, as Russell and Norvig discuss later too, that's been hugely influential.
Though Christian also brings in bounded rationality, Kahneman and Tversky's work, reminding us that perfect rationality isn't always the goal, or even realistic.
A good point. And the idea of autonomy itself has evolved. It's not just about total independence anymore.
Bradshaw and colleagues argued for a more nuanced view, right? Interdependence, how humans and agents can collaborate.
Which feels much more relevant for real-world use cases now.
And thinking about intelligence itself, Christian touches on the progression. Symbolic AI.
Newell and Simon, yeah. Then connectionism, neural nets.
And now these powerful hybrid approaches, especially using LLMs, combining pattern recognition with something more like reasoning.
And newer research is even looking at scale, emergent behaviors in multi-agent systems, social cognition in AI. It's moving fast.
It's also good to see the paper acknowledge influences from related fields. Reinforcement learning, obviously, cognitive architectures like ACTR.
Predictive processing, Friston's work. And importantly, the growing focus on ethics and society. Value alignment, XAI, human-agent teaming.
Okay, so that historical context is super helpful. What about the different types of agents Christian outlines, the typology section?
Right. It provides a useful way to classify them based on what they can do and how they're built. Starts basic.
Simple reflex agents.
Right.
Just condition action rules. Like you said, a thermostat. Good for stable, simple environments.
Then model-based reflex agents. They keep an internal model of the world state, better when things aren't fully observable. Think basic navigation or maybe simple diagnostics.
Moving up, you get goal-based agents. They have explicit goals, do means end reasoning. More flexible. Used in NLP, robotics.
Then utility-based agents. They have a utility function, weighing the desirability of different starts. Good for complex decisions, conflicting goals, financial trading, resource allocation maybe.
And learning agents, absolutely central to ML. They improve based on experience. Recommender systems are a classic example.
Or game-playing AI, conversational agents that get better over time.
And finally, hierarchical agents. They break down complex tasks into subtasks. Think workflow management, complex planning.
And now the big buzz is around LLM-based agents. Agentic AI.
Right. IBM's point about leveraging LLM's language skills but adding tool use, accessing real-time info, breaking down tasks.
That ability to autonomously handle subtasks, that's a significant leap in capability.
And Christian wisely points out, this typology isn't always neat boxes. Real-world agents are often hybrids.
Yeah, mixing and matching approaches. Makes sense.
So let's talk about the recent ML advancements that made all this possible. What's been key?
Well, obviously, the integration of LLMs is huge. As IBM said, they provide that core language understanding and reasoning engine.
But it's the agentic layers on top, as Microsoft describes them, that make the difference. Observation, planning, action.
That whole cycle, that's the shift.
And the foundation models themselves, GPT-3, 4, Claude, Gemini, they provide such a powerful base layer.
Absolutely critical. Then there's memory and context. Huge improvements there.
Sam Schillis at Microsoft really stressed memory for true autonomy, didn't he?
Yeah. We're seeing work on episodic, semantic, working memory, techniques like chunking, chaining information to keep context across longer chats.
Another big one. Expanded tool use. Agents interacting with the outside world.
APIs, databases, even physical devices. IBM's tool calling idea, getting up-to-date info, optimizing workflows, that's incredibly powerful.
Multi-agent systems, too.
Yeah.
Specialized agents collaborating.
Like Microsoft's Copilot example, using background agents for specific tasks. It allows for more complex problem solving.
And the core planning and reasoning is improved. Task decomposition, as IBM highlighted, breaking down big goals.
And we can't forget RLHF, reinforcement learning from human feedback.
Crucial for alignment, getting these agents to behave in ways we actually want.
Exactly, using feedback, human in the loop, to refine them. Though, as Christian notes via Kapoor et al., evaluating how well they actually perform remains a major challenge.
Right. Which nearly brings us to the architecture. What are the nuts and bolts inside these agents?
Okay, core components. You've got perception mechanisms, understanding the environment, NLU for language agents, maybe vision or sensors for others, like IBM says, acting on perceived info.
The knowledge representation, storing what they know. Symbolic, distributed, maybe both.
Then the reasoning and decision-making engine, processing info, choosing actions. LLMs are increasingly central here.
And then action selection and execution, turning decisions into reality. Generating text, moving a robot, calling an API.
Microsoft's point about needing access to computer programs fits here.
And finally, learning and adaptation, getting better over time. Supervised, reinforcement learning, unsupervised, using feedback as IBM described.
On top of those core parts, you often have specialized modules. Planning, definitely. Memory management, Schillis's point about continuity.
Self-monitoring, maybe. Assessing their own performance.
Yeah, metacognitive stuff, communication interfaces, and crucially, safety and alignment modules.
So how are these actually built? What are the main technical approaches?
Krishnan covers a few. Rule-based systems, interpretable, but maybe brittle. Statistical methods, good for uncertainty, learning, but maybe miss complex logic.
Neural networks great for perception, language, but sometimes black boxes.
Which is why hybrid approaches are so common now, combining strengths, like IBM's idea, LLMs plus specialized tools, best of both worlds, potentially.
And specific techniques are getting really important. Prompt engineering, chain of thought.
Guiding the LLM's reasoning. Retrieval augmented generation, RAGs, is massive too. Letting the agent pull in external knowledge.
Tool use frameworks Microsoft again on secure access. RLHF, multi-agent architectures like AWS mentioned with hierarchical systems, lots of active research there.
And that memory and context management piece deserves a closer look. It's critical.
Short-term working memory, like the context window in LLMs.
Right, and long-term storage databases, knowledge graphs, and techniques like chunking and chaining, which Schillis mentioned, to link interactions.
The goal being context preservation across sessions, right? So the agent doesn't just reset every time.
Exactly. No starting from scratch, which involves smart retrieval, figuring out what memory is relevant, forgetting unimportant stuff, consolidating memories, and ultimately personalization across sessions. Super complex area.
Okay, so we have these complex systems. How on earth do we evaluate them properly? This seems like a major bottleneck.
It really is. Christian highlights how current practices lean heavily on accuracy on specific benchmarks.
But Kapoor et al. Critique that narrow focus, right? It can be misleading.
Totally. You optimize for the benchmark, but does it work in the real world? Maybe not. And factors beyond accuracy, like efficiency, cost, they're increasingly important, but often harder to standardize.
We see different kinds of benchmarks, task-oriented, interactive, adversarial.
But they often struggle with long-term interaction, real-world messiness.
And that issue with holdout sets, again, from Kapoor et al., if they're inadequate.
You get fragility, overfitting, agents look good on paper, but break easily.
Plus, the needs of model developers versus application builders might diverge. Hard to pick the best agent for a real task.
And reproducibility. Don't get me started. Lack of standardization makes comparisons really tough.
Human evaluation helps for things like user experience.
Yeah.
But it's subjective, hard to scale.
So people are looking at multidimensional approaches, efficiency, robustness, safety, interaction, quality.
But how do you weigh those?
Yeah.
Standardize them. It's tricky. There's often still a big gap between benchmark scores and actual real-world utility.
Which leads to Krishnan's proposal for a better evaluation framework.
What does that look like?
It's built on several principles. First, multidimensional assessment. Effectiveness, yes, but also efficiency, robustness, safety, interaction quality.
Balancing accuracy and efficiency, maybe using Pareto analysis.
Exactly. And a huge focus on real-world applicability. Domain adaptation, long horizon task integration, user acceptance. Does it actually work out there?
Reproducibility is central too.
Yeah.
Standard protocols, shared data sets, maybe independent verification.
And targeted evaluation. Different stakeholders need different info. Model devs, app devs, and users.
Progressive evaluation stages, from component testing to full system deployment. Continuous evaluation in the wild.
And weaving in ethical and responsible evaluation principles throughout, it's a much more holistic vision.
Okay, that makes sense. Now, the exciting bit, where are these agents actually being used today? What are the real-world applications Krishnan discusses?
The paper groups them nicely. First, enterprise applications. Big area.
The customer service, support, makes sense.
Right.
Assisting technicians, IT help desks.
Business process, automation processing returns, invoices, decision support, analyzing real-time data, supply chain optimization.
HR, talent management self-service agents. Financial operations, reconciling statements.
Knowledge management, maybe an agent accessing SharePoint info. Sales and marketing, lead gen, IT operations support. Lots happening in business.
Then there's personal assistance and productivity.
Yeah, task management, summarizing emails, meeting recaps, drafting presentations, information retrieval and synthesis.
Creative collaboration jumpstarting projects. Personalized learning platforms.
Communication assistance, personal finance tools, health and wellness apps, skill development courses, travel and logistics planning, stuff to help individuals.
And the third category, specialized domains.
Right. Healthcare, medical assistance, financial services analysis, trading, software development debugging, code generation.
Scientific research and discovery accelerating that. Legal research, engineering and design.
Education, training, agriculture, environmental management, urban planning, smart cities. It's really broad.
It is impressive. But the paper also grounds us by talking about the challenges and limitations still out there.
Absolutely. Technically, reasoning is still a big one. They're getting better, but complex logic, common sense, still tough.
Context management over long interactions, that memory challenge we discussed.
Tool integration can be complex. Generalization, getting them to work well in new situations. Reliability, robustness, super important, especially for critical tasks.
Efficiency balancing performance and cost. Multimodal integration handling images, sound, etc., not just text. Temporal reasoning. Scalability, and just the sheer complexity of evaluating them properly.
And then there are the ethical considerations and risks. Huge area.
Privacy, obviously. Accountability, who's responsible when an agent messes up. Bias and fairness.
Transparency, explainability. Microsoft noted agents are still in their infancy here. Safety and control, job displacement, economic impacts.
Overdependency. Security vulnerabilities. Regulation. Compliance. And the long-term societal impact. IBM mentioned concerns about storing learned info and user feedback responsibly. Lots to think about.
Definitely. It's not just technical hurdles.
So given all that, where does Krishnan see the future research heading?
Several key trends. Developing more advanced reasoning architectures is top of the list.
Improving that long-term memory and context management seems critical for autonomy.
Multi-agent coordination, human-agent collaboration, how do we work with these things effectively, continual learning, adapting on the fly.
Multimodal understanding and generation. Better tool use and interaction with the environment.
And, of course, safety and alignment. Efficiency and resource optimization, Kapoor et al.'s point about balancing accuracy and cost. And better evaluation methods are still needed.
What about the really long-term vision? What could this all lead to?
Krishnan paints a picture of, well, seamless human-agent collaboration, agents as true partners,
Autonomous problem-solving on a new level.
collective intelligence, humans and agents working together, personalized, lifelong learning companions.
Augmented creativity and innovation. Maybe even new forms of societal coordination or governance.
Potentially, with a huge emphasis always on ethical alignment, the ultimate goal being, contributing to human flourishing and well-being.
It's a compelling, if slightly daunting, vision. This paper really does a great job laying out the landscape, the progress, the potential, and the very real challenges.
Yeah, it's crucial for everyone in ML and beyond, really, to engage critically with these ideas as the field moves so fast.
Absolutely.
Yeah.
And just a reminder, the link to Krishnan's full paper is in the description if you want to dig into the details yourself.
So maybe a final thought for you listening, especially researchers and practitioners. Where are the most promising, maybe even overlooked research paths that could unlock truly transformative agent capabilities while also tackling these big challenges? Something to chew on.
Okay, Let's transition now to our novel notions segment, taking these ideas and pushing them a bit further.
All right. So inspired by the paper's points on advanced memory, context management, and planning, how about this? Autonomous curriculum generation for lifelong learning.
Okay, autonomous curriculum generation. Tell me more.
So imagine your personal AI agent, right? It doesn't just manage your calendar or find info. It actively designs and adapts a personalized learning path for you across your entire life.
Wow. So it understands your knowledge gaps, how you learn best, your changing interests.
Exactly. Based on all that long-term memory and context it builds up, it could autonomously design a curriculum just for you.
Like a super tutor that's always learning about you.
Precisely. It builds on the personalized learning ideas in the paper, but takes it way further into full autonomy and adaptation. It could constantly monitor your progress
See where you're struggling.
and dynamically tweak the curriculum, pulling in resources, papers, courses, simulations, maybe even connecting you with human experts when needed, all orchestrated automatically to optimize your learning long term.
Okay, that's a cool concept. What's a less obvious link back to Christian's paper?
Well, think about utility-based agents. This agent could be optimizing a kind of learning utility function, maximizing knowledge relevant to your goals.
Okay, makes sense.
And you could even see it as a hierarchical agent, a top-level planner designing the overall curriculum, with smaller agents handling specific modules or finding resources, plus the tool use aspect interacting with all those different educational platforms autonomously.
What kind of impact could this have, realistically?
Huge potential for democratizing personalized education, right? Accelerating skill development, helping with career changes, just fostering continuous intellectual growth. Imagine adapting seamlessly as your job changes or new interests pop up.
Are there downsides? Overlooked implications?
Definitely. Filter bubbles are a risk. If it only learns what you already like, you might miss out on new fields. You need some built-in serendipity.
Good point. And the ethics. And AI having that much influence over what someone learns.
Big ethical questions there. Trust, control, data privacy, all crucial.
So probability-wise, when might we see something like this?
Given the trajectory of memory, planning, and tool use, I'd say medium-high chance within maybe 15, 20 years. The core tech is moving that way. The main challenges will be really understanding individual learning deeply and nailing the ethical framework.
Fascinating stuff. And a good reminder, as always, that our novel notions are speculative explorations. Food for thought.
Indeed.
Well, that wraps up our deep dive into Navine Christian's paper on the evolution and future of AI agents. Thanks for joining us on TalkTensors.
Thank you.